Imagine you wake up tomorrow and the world is reversed. Broken cups leap back onto tables, shards fusing into perfection. Smoke that once curled into the sky collapses back into a match. People speak in reverse. Footsteps echo backward, and every memory you've ever had plays like a tape rewinding. The sun still rises, but in your mind, it is setting. Would this world feel unnatural? Because in our world, time has a direction. Things happen in one order and not the other. You are born, you age, you die, but never the reverse. This is the arrow of time. But here's the cosmic riddle. The fundamental laws of physics, the equations that describe the motion of planets, the interactions of atoms, even the mysterious rules of quantum mechanics, don't care about direction. They work perfectly well forwards or backwards. The math does not force the universe to pick one direction. And yet, reality has chosen. Why? To unravel this puzzle, let's begin with your morning coffee. You pour milk into a hot cup of black coffee. At first, white streams swirl inside, complex and beautiful patterns forming, milk and coffee twisting together. But give it time, and the mixture settles into a uniform brown liquid. Never again will you see the milk leap out on its own, separating back into pure white and pure black. You can record this process, play it in reverse, and instantly know that it is unnatural. Milk does not unmix. Smoke does not return to cigarettes. But here's the weird part. If you zoom down to the tiniest scales, to the level of molecules and atoms, the equations that describe their motion are reversible. If you watch two particles collide and bounce apart, you could play that movie backwards, and it would still look perfectly valid. Nothing in the mathematics of particle interaction says forwards is different from backwards. And yet, when trillions upon trillions of atoms interact together, a direction emerges. Order becomes disorder. Irreversible change is born. This is where entropy enters the story. Entropy is the measure of disorder, or more precisely, the number of possible arrangements of a system. Imagine a deck of cards. Perfectly ordered, ace to king, all suits aligned, only one way to arrange it. Now shuffle the deck. Suddenly, there are countless possible states. Disorder has increased. Entropy has grown. The second law of thermodynamics tells us that in a closed system, entropy never decreases. Things become messier, more disordered, more spread out. This growth of entropy gives time its arrow, but entropy is a concept we live with daily. Ice melts into water, but water never spontaneously forms a block of ice on a summer's day. Your room gets messy with no effort, but it never cleans itself. A sandcastle falls apart in the wind, but the wind never builds one for you. It is entropy that tells us which way is forward, and yet this raises a terrifying question. If the laws of physics are symmetric, why should entropy ever increase? Why not decrease or remain the same? The truth is hidden in the initial conditions of our universe. At the Big Bang, the universe was unimaginably hot and dense, but also astonishingly ordered. A low entropy state, like a cosmic deck of cards stacked perfectly. As the universe expanded, entropy had only one way to go, up, and it has been rising ever since, driving the arrow of time forward. Pause for a second. Think about what that means. You, right now, are experiencing time moving forward because billions of years ago, the universe began in a state of exquisite order. Your memories, your heartbeat, your life story, all are ripples on the great tide of increasing entropy. Without that initial order, there would be no arrow, no past or future, just a static chaos. But we're not done. The arrow of time is not just about entropy, it's also about memory. You remember the past, but not the future. Why? When you drop a glass, you can recall the moment it slipped, the shatter on the ground, the sound it made, but tomorrow you will not remember a glass reforming and flying back to your hand. Our brains, too, are bound to entropy. Memories are created by irreversible processes, neurons firing, proteins changing, information being locked into place. To remember the future, entropy would have to flow backward inside your brain, and it never does. Now let's bring in quantum mechanics. At the tiniest level, the equations are reversible. A quantum wave evolves forward or backward with no problem, but something strange happens when you measure it. Suddenly, probabilities collapse. The particle chooses, and once it chooses, there is no going back. Some physicists argue that measurement itself gives time a direction. Others believe decoherence, the leaking of quantum information into the environment, hides reversibility, locking us into forward flow. The debate is still open, but quantum mechanics whispers a disturbing truth. Time's arrow may not be fundamental at all, but an illusion born from observation and memory. Consider another puzzle. Why do we feel time moving forward, second by second, like a river carrying us away? Physics has no such flow. Equations describe states, not motion. The present is not special in the mathematics. All moments, past, present, and future, exist together, like pages in a book. This is called the block universe view. From this perspective, time doesn't move. We move through time. The arrow we feel is simply our consciousness riding the wave of increasing entropy. Now imagine the far future. Stars burn out, galaxies fade, black holes evaporate. The universe drifts into a state of maximum entropy, where everything is evenly spread, no order remains, no process can distinguish past from future. Heat, death. In that distant silence, the arrow of time may disappear. No more forward, no more backward, just stillness. And yet, not all scientists agree this is the end. Some speculate that the arrow of time could reverse. In a contracting universe, entropy might shrink. Others imagine multiverses, where arrows point in opposite directions, where another universe runs backward compared to ours. Could beings there see us as reversed? Could they be looking at our future as their past? And here's where the paradox deepens. If entropy is the true arrow, then why was the universe's beginning so ordered? Why not chaotic from the start? This question is still unsolved. Why the deck was stacked at the Big Bang is one of the deepest mysteries in all of physics. Some suggest it was a cosmic necessity. Others whisper that we exist in one bubble among many, and we simply happen to live in the one with the right arrow. But think about how this mystery touches your life. Every wrinkle on your skin, every tick of the clock, every page of your story is written because time has a direction. Entropy increases, and with it, your memories accumulate. Your body ages. Your life unfolds. If the arrow of time did not exist, neither would you. Now ask yourself, is time truly real, or just a trick of entropy, a shadow our minds mistake for substance? If the fundamental laws don't care about direction, then perhaps past, present, and future are illusions. Perhaps your birth, your death, and everything in between coexist in a timeless landscape. And yet, to us, time is the most real thing there is. The fire we cannot stop, the current we cannot resist. It is the one law greater than kings and stars, greater than galaxies and black holes. And so we live, we age, we die, carried forward by an arrow no one fully understands. Maybe, in the end, the arrow of time is not something the universe does. Maybe it is something the universe is. So the next time you watch milk swirl into coffee or see smoke rising into the air, remember this. You are witnessing the arrow of time in action. The very thing that makes you human, that gives you a past to recall and a future to imagine. Without it, reality would be frozen, meaningless. With it, the universe writes its story, and you are a line in that story. And as we ask why time moves forward and not backward, we may never get a final answer. But the search itself is what gives meaning to the seconds slipping away. If you found this journey as haunting and fascinating as I did, hit like, share this with those who wonder, and subscribe to Beyond Newton. Because the clock is always ticking, the universe is always unfolding, and together we will keep chasing the greatest mystery of all.